All right, let's go ahead and get started. Good morning, everyone. Welcome to PyCon. First time attendees. Awesome, me too. So we're gonna learn about how to use Python for data science today. This is a little bit of a different crowd than I usually give this talk to, so I'm very interested to see how it goes. Who here is using Python or not? Maybe not using Python on a day-to-day basis. Who's here that's new to Python? A few people. Okay. Okay. How many of you would consider yourself practicing data scientists? Software engineers? Yeah. Anybody else want to volunteer? What? ETL. Okay. Similar? No. Analyst? Grad students? Okay. Yep. And neuroscience. You're in good company then. All right. So I'm just going to quickly kind of go through a few slides about like why we're here, give you a chance to install the materials, but it sounds like most people are good to go on that. The link here to GitHub is where the materials will be for the course if you haven't gotten them already. And then this is a SurveyMonkey link they asked me to share to rate the tutorial this morning. A few other announcements. We're going to have a snacks break at 10:15. So someone yell at me at like 10:10 and we'll get out of here a little early to make sure they're not gone by the time we get out there. And then there's lunch right after this. So I'll be standing between you and lunch at about 12:20. And they said there's going to be food trucks outside the grassy area off the East Mall Drive. All right. So I've already said this about 25 times this morning, but install the materials if you haven't. This is usually a big hang up for getting started, but it sounds like most of y'all are total pros. So we should be okay there. A little bit about myself, who I am, why I'm here. My background is actually in econ. I was a poor graduate student because I got bit by the Python bug. And very early on realized, this is a language that I wanted to be working with, and spent a lot of time building out a lot of the tools that we're now like learning about today and using this week and in our jobs to do data science in Python. And I work at a company, Civis Analytics. I run our R&D department, and I'm also a product lead. So what are we going to be doing today? This is going to be an interactive tutorial. So we're going to use Jupyter notebooks. And we're going to be kind of going through an end-to-end data science problem, ideally, if we get to the end. If not, you're going to have the materials to kind of go through and finish and practice at home. They should be self-contained. We're going to learn how to read data with Python. We may skip over some of the basic Python stuff, depending on how people are feeling, but we'll see. And then we're going to spend a lot of time with Pandas, a lot of time munging data, working with a real-world kind of dirty data set. To get it ready to do some more interesting data science. We're quickly going to look at how to do plotting in Python, what the plotting libraries are, and how we interact with them. And then we're going to look very briefly at scikit-learn. What is it? How can we use it to do machine learning and modeling? And one of the takeaways that I want you to have is at the end of this tutorial, you should be able to write like well-structured idiomatic Python code for data science. I suspect the idiomatic Python code may be kind of old hat to this crowd, but there's some particulars to learn about doing this for data science. So I want to talk just very briefly about what data science is, actually. It's really easy to get bogged down in the tools and the methods and the models because it's really fun, but that's not all it is, and I just want to kind of frame things for everyone here. So there's a few existing definitions that are kind of moving along the spectrum towards what is now the truth in 2018. One of the first early kind of writings on this from Chris Wiggins and Hilary Mason in 2010 was this awesome framework. What does a data scientist do every day? They go out and obtain data, they scrub data, they kind of explore the data, and then build a model, and then make sure they can actually interpret that model, make sure it's usable. And that's, I think, pretty good, and that is like the nuts and bolts of what we do all day, but it's missing a little bit the why maybe. There's another kind of O'Reilly pamphlet that came out in 2013 that's based on talking to a bunch of data scientists, kind of survey of data scientists. And their kind of working definition was, a data scientist should have the ability to create prototype level versions and the steps needed to derive new insights or build data products. So the idea here was build something that is bordering on an application, like a full-fledged production application that allows you to kind of get data scientists in the data science into the world to be making decisions and backing products. So the kind of where we are today, I think, is like data science exists to drive better outcomes, kind of period. If you're not getting the data science out into the world, then it doesn't really matter. This is something that, you know, seems obvious, but it's something that I have to or I get to harp on with my team over and over and over again. Like, okay, why are we doing this? So these are some of the outcomes that can be driven by data science. It's really easy to get caught up in the scrubbing, the modeling, and just having fun with the tools. But if you're not driving towards some kind of outcome, then you're not going to be able to have an impact. So now, how do we actually do it beyond just the nuts and bolts? We collaborate across disciplines. So on my team, we have a statistician, civil engineer, all stripes of physicists, someone from an evolutionary biology background. My background is in econ, people that come from consulting, computer science, software engineers, and we all have to work together. How do we work together? You know, we share the common language of mathematics. That's part of it. That's very helpful. But increasingly, we also share a bunch of processes. And we do a lot of borrowing from software engineering. So how does software engineers work? How do products get built? We spend a lot of time thinking about that, and I think that's something that's very important for data scientists to take away, and something that's not obvious to them, something they haven't necessarily been exposed to over the years. And one of the things that's pretty key to this is the use of open source languages. So increasingly, everyone is using Python, everyone is using R to get their work done. And today, we're going to be focusing on Python. I'm not sure I need to beat this drum here, but when I give this talk at our tutorial in different venues, one of the first questions I get asked is, should I learn R or should I learn Python? It's like, well, I have an opinion, but I don't usually give it. Python is a choice. It happens to be a particularly good one for a variety of reasons. It doesn't sound like, you know, this is new to y'all, but there's going to be a ton of packages that you can use to do data science. We're going to look at some of the core ones today. That makes it really, really helpful. There's a lot of robust libraries for testing. So one of the key parts of data science is being right, or at least knowing when you're not right. So following good software practices, doing unit testing. This is stuff that's usually pretty new to someone coming out of a grad program or someone transitioning into data science who doesn't have a software engineering background. They don't think about correctness of code. They don't think about well-structured code, these kind of things. But the Python community makes this, and the tooling makes this a lot easier for data scientists to do. It's really easy to write defensive code in Python, and we'll look at some examples of what does defensive coding look like for data science. The whole concept of readability counts and style matters in Python, that carries over to the rest of an organization and is really, really nice. Python makes it really easy to go from prototype to production. So we saw the definition earlier that said you should be at least able to write prototype level code. But the beauty of Python is, depending on how your software engineering team works, you don't have to throw things over the wall and have them re-implemented in Java and deploy. They have the option to continue to write in Python. With other languages, it's a little more difficult. And you know, we're all here at PyCon, so I don't have to tell you about how awesome the community is. But the community has been very helpful for me getting started over the last decade. Very forthcoming, forthright, and super, super helpful. So that's one of the things that I really like about Python. I always like to note, while I have a soapbox to stand on, just some brief words on sustainability. So we're all using open source tools. We're all here using Python, supporting Python, but it doesn't get done on its own, right? It relies on community contributions, right? Python doesn't have a corporate sponsor, big corporate sponsor behind it, making sure that things keep going. So I just encourage people, if you're using Python, if you're using Pandas, if you're using NumPy, scikit-learn at work, to ask your employer to give back somehow, either through in-kind contributions, allow you to make contributions like documentation or bug fixes, feature pull requests, that kind of thing, or monetary support. and a great organization that you can give to that supports the community, that supports building the kind of scientific stack, if you will, that underlies all of this is NumFocus. And if you're not familiar with NumFocus, I highly encourage you to check them out. Okay, so I've asked you a few questions about who people are already. Is there anybody who's new to programming? Some, okay. And it sounds like, so the people that are new to Python, have you ever used Python before, or never used it, never seen it? I'm gonna stand here awkwardly until I get a good answer. I want this to be super interactive, so I'm gonna be walking around. We're gonna be like taking breaks, going through exercises, asking questions, so please feel free to speak up. Are there people that are new to data science? Who doesn't do data science on a day-to-day basis? Okay, almost everyone, good. That's why this is Introduction to Python for Data Science. Okay. Is there anybody who's new to Jupyter notebooks? Okay. So if you follow the instructions in the GitHub repo and get to the opening up of the Jupyter notebook server, you get this page. Is everybody on this page on their machine? Is anybody not? Do you need help? So go to the GitHub repo, and there should be instructions in the README for installing all of the packages, and then in the end you'll get to a line that just says you type Jupyter Notebook at the command prompt or terminal, and it'll pop up the Jupyter Notebook server. So what is the Jupyter Notebook? It's an interactive environment for doing literate programming. So it's a place where you can write Markdown, you can write HTML, and you can write Python code and execute Python code. It's a great way to learn to do tutorials like this, but also to share code with your colleagues and coworkers, or co-authors, as the case may be. It's been pretty invaluable for me. So there's two things. We kind of have a decision point right now. Would anyone find it useful to go through a basic Python tutorial? Like what is Python? What are the basic data structures? We can spend 15 or 20 minutes doing that. No? Yes, a few people. So let's just look at it for like 10 minutes or so just to get our feet wet. And those of you who have not used Python before can spend some more time with this during the exercise breaks. Then you'll have it too also to go through. And there's some great tutorials linked in the README for getting started with Python. So I'll skip a lot of the detail here. But the basics of Python is it's an interpreted language. It was the first interpreted language that I ever used, and it kind of blew my mind that you could program like this. I didn't know about a REPL. You can type in things and immediately get back a result. And in Python, whitespace matters, so there's no braces like in other languages. You can just indent your code. And Python is meant to be read, right? So the entire design of the language was, they had in mind this idea that, people read code, so much more than they write code, so readability counts. So all of the constructs in Python should ideally read like English. So what is a module? A module in Python is just a file that ends with .py and contains some code. And we'll look at a bunch of examples of modules. The first thing I like to show people when you're getting your feet wet with any new programming language is how to get help, how to help yourself. So here, range is a built-in function in Python. And every function, every class, every object should have what's called a docstring. So here, let me make this a little bigger. So here, I'm printing the docstring for the range function. The double underscores here is called a dunder, and it's just kind of a Python convention. And if you're in IPython or Jupyter, as it's now called, you can just use the question mark. So you can type a question mark after the function, and if you're in the Jupyter notebook, it pops up this little modal that you can use to browse the documentation. So that's going to be pretty handy as we go through some of the exercises, because a lot of it will involve kind of poking around and figuring out what you can do and how. Comments, again with the hash. Print is now a function, so we're using Python 3 today. The one thing to note about arithmetic operators, if you come from, does anybody like who's new to Python, like have you used R or MATLAB? Some? Okay. So one thing to note about the arithmetic operators is that exponentiation in Python is 2 asterisks. It's not a caret. And in Python 3 we have float division. So if you want to force enter division, you have to use 2 forward slashes. Assignment is done with equals. This may seem like old hat to you, but if you come from R, there's different ways that you can do assignment. And to get rid of a variable in Python, you can use the del statement. But note that this doesn't necessarily free up memory. That's left up to the runtime. So if you're starting to do things that require like heavy memory management, you're not going to be able to rely on del necessarily to like immediately free up that memory. So you need to be a little careful about that. Lists in Python, so these are some of the core data structures, and we're going to come back and see how things like Pandas, things like NumPy extend the core data structures in Python. So in square brackets here is a list. The one thing to note about a list is it's mutable. You can change it. Python uses zero-based indexing, so the first element in any list is 0. And we index in using the square brackets here. You can use negative indexing, so we can go from the back, and we can actually change things. So one kind of gotcha from people that are new to Python from other languages is that Python is pass by reference, so it doesn't copy the data here. So if we take A, assign it a list, give that to B, and then change something in B, it goes back and changes A too. So this is kind of a can be a stumbling block for people getting started. So the question was, is there a good way to prevent that? How do you make a copy? There's a few ways to do this, and we'll see with Pandas and NumPy. This is the shortcut that I like to use sometimes. So we're going to get into slicing actually next, but this is a way to copy an array or a list in this case, and we'll talk about kind of how that works in just a second. So taking a slice, however, does copy. So in this case, if we want to just take the first few elements, 1 and 2 in this array or list, then we can use slicing. So this actually does copy. So you can see now we assign to the first element a new number, and it doesn't go back and change A. So when we take a slice, we do get a copy. And this seems fairly in the weeds, but this will be important when we work with different data structures in Pandas and NumPy. So this is the syntax I showed above to copy the whole list. So now B does not refer to the same memory as A. And here's a few other ways to do that. Lists can contain any kind of object. So here I put a list in a list. And I already kind of showed you above the range function, but here's what it actually does. It creates an object that we can iterate through. So here, if we wanted to make a kind of range object from years 1996 through 2012, this is how we might construct that. So tuple is another like heavily used data structure in Python. The big difference between tuples and lists is just that a tuple is immutable. So you can't actually change it. Strings, you can use either single quotes or double quotes. Be consistent. That's kind of the one thing that you want to take away, and that strings are immutable. So this kind of surprised me when I was getting started with Python. You can't change a string, but you can iterate through it, just like any other kind of iterable container. But if we try to assign to it, it'll say you can't actually assign anything to a string. Dictionaries in Python, so this is the implementation of hash tables in Python. It's a key value store. All of the keys have to be immutable. They can't change, so you can't make a list, a key in a dictionary, but they can hold anything. And so here I make a key value store, and we'll see how Pandas is kind of like an extension of dictionaries in just a second. And actually very early on, Pandas was dictionaries under the hood. That's no longer the case. But so we can use, again, the square bracket syntax to pull out the values from the dictionary using the keys. There's also several methods that we could use to do this. In this case, we can use get and try to get a key that doesn't exist in the dictionary, and then it returns none in this case. It can be handy. So a bunch of you are new to Jupyter notebooks. So how can you kind of start to get oriented in a Jupyter notebook? First, there's help. The first thing I do with any new like IDE or any kind of software that I'm working with is look for the keyboard shortcuts. So the Jupyter notebook has a bunch. If you want to know how I'm doing anything, just stop and ask me. But this is pretty comprehensive. This is also extensible if you want to change things. So here I type A because I already have a list that I've created above called A, and then just hit tab. And it pops up all of the methods that you can use to do anything with any object, actually. So, and if you open parentheses, it'll complete them for you. And if you want to get help, you can hit Shift Tab or Shift Tab. Will make it's another way to get the help documentation versus using the question mark. So here it actually pops up versus showing up in a little window at the bottom. Control flow tools, we won't use a ton of this today, so I won't belabor it, but it's if, elif, and else. For loops, fairly straightforward. For blank and blank. And now we're iterating through the iterable. Python has while loops. And if you want to break out of a for or while loop, you can use the break statement. If you want to skip over a code block, you can use the continue statement. So if I want to stop here early, I can use break. And here, if I want to kind of skip the code block below and not print I here, I could use the continue statement. So you see I don't print 5. How do we define functions in Python? So this will be handy. We use def, and then you see here we create a function square that takes x and returns x squared. This is how the doc strings that I talked about above are actually implemented, so they're written in triple quotes. We'll come back to lambda. This is square with like a good doc string. The doc string actually fleshed out a little bit. And I don't think we need to introduce classes. So a few things to note about IPython and Jupyter. This may look kind of odd, but any function or any kind of statement that I use that starts with a % sign is what's called an IPython or Jupyter magic. So this is not part of Python. A lot of the impetus for IPython was for scientific work. So a lot of these things were helpful little shortcuts, handy shortcuts that the Python built-in interpreter doesn't actually have. So something like time it will just run the code a bunch of times. You can control it through flags and arguments and tell you how long the kind of wall time, runtime was for that code. So if I want to time this function, I can just call time it. And here, since I'm using the Jupyter notebooks and have a flag turned off, I can omit the % sign, but it's good to know what's going on. So time it's like the most handy one. I feel like I use that all the time. The paste is also helpful too. So paste your clipboard into the IPython or Jupyter Notebook interpreter. You can use paste. So that was the world's fastest introduction to Python. Any questions about that? Like I said, I kind of encourage you to mess around with this notebook a little bit if this is your first introduction to Python, and stop me and ask questions as we go along.
I've never seen the paste one. How did that? You copied something from somewhere else?
So the question was about the paste one. That's perhaps new. So here I just copied this for loop, and I can just do, it may be gone. It doesn't exist in this. This is maybe just a IPython thing. So let me see. This is Python 2. This is an old notebook.
What's the attendees for a terminal that shows the branch name?
What was the question? In my terminal, how do I show my GitHub branch name? You can go to my .files repo if you want to see how I do that, and we can talk about it at the break if you want. But yeah, so I just fixed this, copied it, and then paste. And it just executes the code. So that's really, really handy. So a lot of people kind of ask me when they're getting started, like, what should my stack look like? What should my tooling look like? I like an editor and an interpreter. If you use Emacs, like you can hook it up with IPython a lot easier. But I use Vim a lot more, and so just copy pasting back and forth in a way that's kind of not super convoluted is just use the paste function. I just put things in a clipboard and go in, type paste. And I'm like iterating very quickly. And then how do I set up my Z shell? You can go to my .files repo, like I said. It's Seabold .files, and poke around. So I'll say a few words about what it means to be Pythonic. I've already kind of set this up a little bit. But what does Pythonic mean? You'll hear that a lot, probably a lot this week and this weekend. Like, what does it actually mean? It means to write Python code in a way that's idiomatic. You write Python code that looks like other people's Python code. Why? Well, we'll get into the why in just a second. If you've never seen the Zen of Python, this is one of the Python Easter eggs that exists. I always like to start here because this is core to the language and it's core to what we do, and it actually bleeds over into the data science world because this is just like good advice. It's good programming advice, and it also is good advice for data scientists. Complex is better than complicated. Like I don't know, I find myself saying this to my team all of the time. Sparse is better than dense, and readability counts. So readability counts is the very super, super important one. So I've already mentioned like how Python was designed for readability. This is a quote from the old classic textbook, Structure and Interpretation of Computer Programs, that programs are meant to be read by humans and only incidentally for computers to execute. I think for a lot of us, we realize that this is certainly the reality. And just a very brief plug for this book, we did a reading group at my work where we went through this and went through it with different languages, went through it with Python. It's a computer science textbook from the 70s that kind of builds up this some of the ideas of computer science from first principles. And it was really instructive for people that are trained as data scientists and not necessarily software engineers to step back and start to think about things like this. David Beasley teaches a course using Python to go through this textbook in Chicago. If that's something you should check out if you're so inclined. So when I'm talking to data scientists, talking to scientists, talking to people that just want to like get work done, they say like, why does any of this matter? If my script works, if it runs and gets an output, like, isn't that enough? So no, it's not. Like, why? I mean, a lot of these people a lot of data scientists come out of academia where you spend like 7 to 10 years working quite often in isolation on some code and never kind of think about what's next. Well, what's next is somebody's going to read your code. You're going to publish it. What's next in an organization? You're going to like share your code with your colleagues. Someone's going to code review it. You're going to come back to it 2 weeks later, and if it's been 2 weeks to 6 months, someone else might as well have written the code. So also, I mean, at the very least, be kind to your future self, and also maintainers of your code. Like, I don't know how many of you have inherited a legacy project at work or inherited a legacy research project and just said, I'm going to start over. I can't understand this. I can't work with this. And that's bad. It's bad for science, it's bad for data science, and it's bad for your organization because you're wasting time. Oh yeah, and it's just one less thing to worry about. So you don't have to like argue about things like code style and all of that, because we have in Python kind of an accepted standard of how we work, and that's PEP 8. How many of you are not familiar with PEP 8? A few people? Okay, so PEPs in Python, this stands for the Python Enhancement Proposal. This is how changes to the core languages get made or adopted. In this case, I guess this was the 8th one, and it was we're going to settle the style debate once and for all. This is how you should write Python code, and these are like the acceptable standards, and you should probably adhere to them just so we don't have to talk about it anymore. But they also help with the readability, and they help with understanding. And so when you go look at a Python project, if you want to go look at the Pandas source code, or you want to go look at the scikit-learn source code, or NumPy, or any other project, it's going to look the same. You're not going to have to go, whoa, how do these people think? Like, what is the style for this project? And it's one less thing to worry about. And so getting into the source code for any of these projects is it's easier, and it happens a lot more quickly. So some of the top level takeaway rules, spaces over tabs. So use spaces and use 4 of them for indentation. Limit lines to 79 characters. This is a holdover from the days of punch cards, but also now like makes it so that you can have several windows open next to each other and read code. And then be very specific when importing. So use names, be explicit. Explicit is better than implicit is one of the lines in the Zen of Python. So prefer something like from the time package import time the function rather than from time import everything. So you're allowed to do this, but it's discouraged because you don't know where functions came from. If you import something from time, I have no idea what's in there, and I may have clobbered a function that I wrote. I may have clobbered a function that came from another package. So it's best to avoid doing that. Another convention to note is that non-public names, if you come from other languages, there is no actual strict private versus public functions. So the way that people signal to other people in Python that you shouldn't use this function or don't rely on it, not changing, I'm making no guarantees about this function, is to start it with an underscore. So if you see a function that starts with an underscore, you can use it just like any other function, but it may break tomorrow. It may break 2 years from now when you go back and try to run this. There's no guarantees about it. Use cap words for classes. So when you see a class in Python, if you see something that starts with uppercase, then that's a class. If you see something that starts with lowercase and has underscores in it, that's a function. It's different than other languages, but it's so ingrained in Python. When I go work in Go or go work in some other language, when I'm reading JavaScript code, it takes me a second. It's like jarring. So this is it's a pretty strict convention. Yeah, question?
Can you speak again to the, you mentioned if you see a function that starts with an underscore, don't feel it's safe for future use? I missed the part of that.
Yeah, so there was a question about the private names. If you see a function that starts with an underscore, I can't think of a good example off the top of my head right now, but the admonition is that this is the way for whoever has developed that function to tell people that they're not going to maintain it. I need this function right now, but I haven't fully thought through how general it should be, how useful it's going to be. So like the interface to the function may change, or the like actual what the function does may change in the future. It's just a way. It's like I said, this is a convention. It's just kind of an accepted thing in the community to be like, oh, okay, so I can use this, but caveat emptor, caveat developer. It's up to you to take on the risk, right? So there's no guarantee that this is going to be maintained. It may even get deleted and go away. So if you start to rely on functions like this, like if you import from Pandas, there's probably 100 of these. And if you start to import these functions and use them in your own code, even though they solve a problem that you have, undoubtedly it's a problem that the developers had, you may have a bad time somewhere in the future. So I'll even copy and paste some of these functions into my code, and now I'm maintaining it, and I understand that I'm maintaining it. I'm not implicitly relying on something else that someone's explicitly said they're not going to maintain. Does that answer the question? Yep. Last bit of advice and this all kind of speaks to this concept of defensive programming that we'll come back to, but use a linter. So if you're using PyCharm or Sublime or whatever editor you use or IDE, it's really easy to go in and install a linter that will tell you if there are syntax errors in your code or if there are style errors in your code before you run your code or before you check it in to a repository for someone else to read your code and be like, hey, you broke our style convention here. You want to avoid those conversations. It makes you faster. It makes you less error prone and able to iterate faster. I really come to rely on this. Okay, now let's start to do some stuff. So earlier we kind of introduced this awesome framework, the obtain, scrub, explore, model, interpret. What we're going to focus on first is obtaining data. So how can we use Python, the core Python itself, to go out and obtain data? We're going to go through this fairly quickly, but I promise we are going to slow down and dive into some of the code, but I want to make sure we get to some of the more data science packages versus what you can just do with Python itself. But this focuses on just using Python itself to obtain code. Say we want to open a file in Python, we just use the open function. So everybody, so there was a note about this in the README. Depending on how you actually unzip the data file, sometimes it'll unzip to a subfolder. So I actually used Finder here to do this, and in Windows, if you click and extract, so you need to go in and move the data. So you can see I'm in data. We need to go and move all the data up a level. So now all the data is in the top level data folder. So if you try to run this code and run into an error, that's what's going on. So now I have an open file handle. So one interesting thing about Python is that file objects, so I've opened this health inspection sample data set. It's a CSV, but this hasn't really done anything. It hasn't loaded this file actually into memory. So file objects in Python are what are referred to as lazy iterators. So we can walk through this file, but we have to explicitly walk through it. So it's not going to just, if you have a 100 gigabyte CSV, which I'm sure you do at some point in your career, you want to load it, but you're going to have to be smart about how you go through this file, and Python allows you to do that. So one way to get the next line in a file is just to use the next method. So here, this is the headers of this CSV file. So what this actually is some health inspection data from restaurants in Chicago. And we're going to clean this data up and try to learn something about how health inspections work in Chicago right before lunch. Should be fun. These are some of the variables that are in it. So the address of the business. So where do we go? Otherwise known as name. What city they're doing business as name. What type of facility is it? When was the inspection date? What was the ID? What was the unique identifier for this inspection? Where is it located? What was the result of the inspection, and what was the risk level of the things that we discovered? And then a large kind of almost free-form text field on violations. So what did we actually find? So one of the reasons that we're using Chicago is I first tried to write this using the health inspection data from San Francisco. It was too clean. So it was just really, really well formatted and really well thought out. So it did not make for an interesting tutorial. You just kind of were like, oh, okay, I can just immediately use this for modeling. So kudos, San Francisco. Chicago, we have some work to do, but thank you for everything that you do. Okay, so here we saw that we used the next method to get the next object in an iterator. In this case, it's a file. So what did it do? It returned me the whole line, first line from that CSV file. If you go look in the CSV file, this is the header row. I almost never do this. So I use next sparingly. I don't know. I don't find myself needing to use it all that much other than just peek at something or try something out. I don't ever really use it in code. So how do you actually work with these files in practice? You just iterate through them. So any iterator, you can use a for loop, and you can iterate through it. So I don't think I introduced earlier the pass statement. This is just a way to say I don't want to do anything, just keep going. I got a lot of questions about this before. Why would you use this? This is one reason. I don't want to do anything. I just want to show you how to do a for loop. So pass, don't do anything. So here's the actual last line in this file. So after using a file, you need to close it, or eventually your operating system will yell at you if you keep opening files. So we always have to type close. I only bring this up to show you the next construct in Python. So this is what's called a context manager. So anything that happens below the with statement here happens within the context of open. So open defines some kind of rules about what happens within this block of code. So you see I use with open, and then I say as. So now instead of CSV file equals open, I use with and as. So it's the same thing, but then I have to indent all the code below it. Why do I do this? So I don't have to call close. I don't have to remember to call close. So as soon as you exit this context for the code, it calls close for you, and I don't have to think about it. So you'll see this quite a bit, and it's just kind of another one of these idioms. This would be an example of Pythonic code for, in this case, reading in a file. Is that clear? So the question here is, what is line here? We defined line above. We've already iterated through this file. And is it different? Yes, it's different. As soon as you start iterating through this, this is a new variable. It has nothing to do with the variable above.
So they're not scoped within the width. Sorry.
This is scoped within the width, but not outside of it, right? But now it's defined. So it doesn't take anything from above. This is a new line, and then you carry it outside. So it doesn't destroy variables that you create within the context manager. This is not, the question was, is this line from above? Yeah, no. So the variables will live on. All that happens here is the cleanup is closing the file for you, closing the file handle. So I think I'm actually going to skip over this exercise because it's not very interesting. Yeah, question?
So a follow-up question to that. So in I think it's cell 7, where you say you make line equal to the next, you iterate the next line in the CSV file?
Yep.
That, if I understand this correctly, that's sort of tracking the state of where you are and giving you one after the next.
Yep.
But later on, when you say print line, how do we know which, does line, if you know, does it always fast forward to iterate through them all and give you the last? Or is it tracking whatever the state was and says this is the next and that's it?
So that's a good question. The question is kind of about like how should I think about what the variable is at any point in time given the code that we've executed, I think. And that's actually can be tricky in notebooks, and this is one reason people like don't actually like notebooks all that much, especially if you're a programmer. Like I don't know. So I'll editorialize for a second. I don't usually like develop code. I don't develop production code. I don't develop in notebooks. I use them to iterate on an idea, and then I quite often go to my editor and start writing code because it's a lot easier to reason about, and it's just like how we write and ship code. So I use notebooks as like a quick iteration and share with my colleagues, but and the reason is because the notebooks are stateful. So what is line in this case? It's whatever the last thing line was, no matter where you are in the notebook. So in this case, line is, it's not that first line from CSV file that I opened earlier. It's the last thing that I defined it to be. Does that answer the question? Yeah, so the notebooks carry state around. There's a few projects that try to change that behavior, but it's something to note. Like when you execute a notebook, if you start going out of order, you can get a little confused. But if you stop and think, the notebook actually carries state around. I think it should be clear, but it can trip you up. So quite often the first thing I do to make sure I haven't messed this up, the last time I did this tutorial, is run the whole thing. And does it run and does it give expected output? Or you could even write unit tests or something in there. I think there's a talk this week about unit testing in notebooks. But yeah, that's a good question. So I'll kind of just show you the answer to this because I think it's a lot more fun and a lot more instructive to get to Pandas a little faster. So the exercise here was to try to iterate through this file twice, but only call open once. And we do this for a couple of reasons. And so this is another one of these Jupyter magic. So any of the exercises that we're going to do today, they'll have solutions. You could just run this bit of code here and get the solution, but I encourage you to try before we do this. But for this one, we're just going to go through it. And I give a hint here to use the tell method because I ask you to say how many characters are in this file, and tell will tell you like, well, at least how many bytes are in the file, where you are actually in the file. So let's look at this and then talk about it a little bit. So there's another file. There's a JSON file of the health inspection data in this directory. So here I open up that JSON file, iterate through it once, and then ask that file handle, where am I in the file? So the answer in this case is going to be I'm at the end of the file. So this is how many bytes are in the file. So what I've done is step through this entire file, and I'm now at the end. And the point here is that when you iterate through an iterable in Python, you consume it. So in the case of reading a file, I have to go back to the beginning of the file. So I have to use the seek method to go back to the 0th byte to iterate through it again. I couldn't just, if I tried to do this, it wouldn't give me an error, but it wouldn't give me any lines. It actually wouldn't iterate through the file because you're at the end of the iterable. Question, yep.
Why did you need the print O is the print, sorry, the print zero? The print statement is just to explain what's going on. You could iterate twice just by going back to
Yep.
zero.
Yeah, the question was, is the print statement just to explain what's going on? Yes. So the print statement is just like, oh, wait, how many bytes are in this file? Where am I? Tell me where I am using the tell method.
You don't need tell to iterate twice.
No, you don't need tell to iterate twice. This would work. Like this, I just iterated through the file twice. And incidentally, I don't know that I mentioned this, I hit Control-Enter to run these cells. So if you're asking yourself, how do I actually run code? Control-Enter, or if you hit Shift-Enter, it'll then move you on to the next cell if you're new to Jupyter Notebooks. So you can use Python to read CSVs, and I'm going to very briefly talk about this, only so that I can show you how to do it in an easier way using Pandas in a second. Point being that you can get pretty far with the core Python language to do data munging, to do things that are going to enable you to do data science, but the tools are there to make your life a little easier because we banged our heads on this stuff for a very long time before making some better tools.
Also, NumPy has some optimizations support.
Yep. The comment was there's also some optimizations in things like NumPy and Pandas that can make things a little faster. So we'll see NumPy arrays in a bit after the break. But yeah, so the core Python language was not necessarily designed for numerical computing. It just happened to be so lovely and nice that scientists came along and realized they could use this to do scientific computing. As well as web dev or whatever else Python may enable us to do. But there needed to be some kind of faster C extensions under the hood to allow this to happen in a way that could make sense and allow us to do our work. One note, pprint stands for pretty print. I use it a lot when I'm iterating to print a dictionary or print a list in a way that's a little more readable for a human. So I'll use that here. And I import the CSV module. So now we have this reader object that is a lot like a file handle in that it's lazy, but it'll do some nice things like parse out this CSV for us. So here I use the next method to get the first line from CSV reader and pretty print it. And now we see that we have, instead of just like a one string with the commas that we're going to have to go out and parse, CSV reader went in and parsed all of this for us. It'll also handle things like missing values and stuff like that for us. So if we take the next line, we'll see now that we have a list and all of the columns of the CSV have actually been parsed out. I'm sorry, what was the question? So can I use pprint? The question was, can you use pprint to print dictionaries like a key value store? Yes, that's where it really starts to shine. And I think I actually show you how to do this here. Let's see. So I want to just briefly talk about this, mainly to make a point and about why we're working this way and like what this is starting to look a little complicated, a little complex. Like what is actually going on here for those of you that are new to Python. So I'm going to read the CSV file. I'm going to do it within a context manager. We saw why we used context managers earlier. So we could just close the file. And then I introduced this new concept of a try except block. And why? So, and what does it actually do? So first of all, what's happening in the try block? I'm using this sniffer from CSV. So what does this actually do? It peeks at the file and tries to guess how it's formatted. If any of you work with CSV files on a day-to-day basis, you probably also curse at work because someone has invariably given you a CSV file that is like ill formatted. That's either, oh, yesterday they were giving me comma delimited, today they're giving me tab delimited. You know, it went through a Windows machine, it went through Excel, the new lines changed, and I have to go back and fix something. Sniffer is a way to try to read part of the file and just figure that out for you. So if I want to write a function, in this case, like defensively, if I want to defend against my coworker changing the way that they save their files, this is one way that I may be able to do it. So I sniff, you know, the first few bytes of the file to go, okay, what is the actual dialect of this file? How is it formatted? And then we go back. So we've consumed part of the file, so we have to go back to the beginning of the file to read it. And then we say, okay, we know what the dialect is. Go ahead and read this whole file in. So what is this try except else doing? So try to understand, try to sniff out the file, but like sometimes they may give you, oh, I forgot, and I gave you an Excel file where I passed it to your function, and you hadn't accounted for that. You hadn't accounted for all of the possible inputs that your user can give you. So one of the ways to avoid just like raising a crazy error for them is to use a try except block. So try to do this. If there's an error, so except, catch anything. So in this case, it's a CSV.error. Gets raised, catch anything that looks like this, and then print out some useful information for the user. So tell them the format of this file could not be detected. So this is in this case like this may be like more logging than raising an error, but we can use print to just give some information and kind of make our point. If there's no exception, then execute the code in the else block. So go back to the beginning of the file and read it. So this is like one way that I'm like the first time I write a function that is accepting input from people, hopefully CSVs. This is what I may have at the top of my function just to make my life and their life easier later. Is that clear? Is the try except block clear? Yep. Okay. I'm not going to go through this in detail, but there you can do some pretty handy stuff with try except blocks and be very explicit about the errors that you're catching, because you don't want to silently catch all errors. That's a great way to hide bugs in your code, and it's a great way to make things harder to debug. So you want to be explicit about the errors you're catching. So above I caught CSV error, but like what if that file didn't exist or something like that? It may raise a different error, and I didn't want to tell them that I couldn't understand the file format when the file didn't actually exist. So I was being very explicit about the error I was catching. We'll go through this a little bit just to look at what JSON actually is, and then I think we'll take a break and get started on Pandas after the break. I may just say a few words about it. So JSON is another common format. So if you're working as a data scientist and you're going out and having to obtain data to do your work, you're quite often hitting some kind of RESTful API, some kind of web API, and almost always that data is going to be returned in JSON format. For all intents and purposes, for us today, JSON format looks a lot like a dictionary. So here I've saved the file in a way that it has all of the column names in each line of the file. So address, here's the address, otherwise known as name. This is red snapper. And we can use the JSON module to load this in. And I'll show you again this to show you how easy it becomes with Pandas in a bit. So here I start an empty list, iterate through the file, and then use JSON.load. So iterating through a file returns a string, and then we're going to use JSON.loads to take that string and put it into a dictionary. And then we save this in a list. And there was a question earlier about can I pretty print dictionaries? You certainly can, and you probably should, because this is a heck of a lot easier to read than something like this. But you can see what did JSON loads do? It took this file, parsed it out, and put it into a dictionary for us, or it took this line, parsed it out, and put it into a dictionary for us. So another Pythonic concept, something that we're going to see a little bit more this morning, is what's called a list comprehension. A list comprehension is a way to create a list using an incantation that looks a little bit like magic and maybe a little foreign, but it's, again, one of these concepts that you'll see again and again, and is an example of Pythonic code. So here, if I quickly wanted to make a list, I can put the for loop on a single line and put it between square brackets, and it'll go through range and return me this list. The alternative is that we write a bunch of code that looks like this, and this is just a little more compact, and it's actually more readable once you can kind of grok what's going on here. List comprehensions can contain logic. I only mention this to tell you that I can never for the life of me remember the syntax for this. I've been using this for over 10 years, and I have to look it up on Stack Overflow every time. So don't expect the things that we learn here today to immediately sink in, if ever. Okay, so now we're going to get into pandas and start to get into some exercises and some much more interesting code. So a bunch of you said that you, well, maybe I didn't ask. I don't think I asked about pandas. How many of you have never used pandas before? Everyone. Yeah, that's awesome. Welcome to the first day of the rest of your life. So pandas is a great library. It's become the kind of this core package it's built on top of a bunch of core packages we'll talk about later, but it's become this core package for doing data science in Python, for doing data munching in Python, for manipulating data, and just generally it makes Python even more of a joy to use. So one of the brief anecdote I like to tell people is, so I started working in Python before pandas existed, before a lot of these packages existed. I was doing dissertation work. I was working with data from economic development. It was narrative data, it was text, it was numbers, it was integers, and all mixed together. And I used NumPy, just NumPy itself, to read in this data, try to hold it and try to clean it. And by the end of it, it took me all week. And by the end of it, I had something like 1,800 lines of code. And then Pandas came out, and we started working on it. And I went back and rewrote that code, and it ended up being like 3 lines. And I was like, oh, there is a better way. I don't know. Maybe says something about how stubborn I am, but Pandas is like kind of saved my life, and I think a lot of people have come to really rely on it. So what is it? So it's a package that provides some data structures that make it easy to work with relational or labeled data. So if you're familiar, how many of you are familiar with SQL? Yeah. So this Pandas, like in the way that you think about data and the way that you work with data, if you're used to working with SQL, should be pretty familiar. And if you're not, I think it'll still be pretty natural. So when do you reach for Pandas versus anything else? If you have tabular data, so like a CSV or an Excel file or something that comes from a SQL database, then you may want to reach for Pandas. If you have heterogeneously typed columns. So what does this mean? So you have a mix of strings. You've already seen above, we have a mix of strings. We have a mix of integers. We have categorical data. So we'll come back to categorical data. Pandas makes it easier to hold all of that in a single object and operate on it. Whereas if you just had numerical data, so if you work in the like earth sciences or astronomy, you probably just have pure numerical data. If you work with images, you may have pure numerical data, and I envy every single day of your life because it's a lot easier to just work with numerical data. Pandas makes it easy to work with kind of messier data about like people or that kind of thing.
Can you have mixed types in single column?
The question is, can you have a mixed type in a single column? Yes. And I'll go ahead and say one thing that I'll probably end up saying in a bit anyway. The question for can I do X with pandas is always yes. And it's been a slow burn and developing up over time. A lot of the functionality of pandas, but the answer is almost always yes. Another piece to note while I'm just doing some intro is that if you find yourself writing really complicated pandas code, and we'll see how this could come about. This is some advice that Jeff Reback, the maintainer of pandas, now gave that in a talk that I really liked and now use. If you find yourself fighting the API, you probably missed a piece of the API. There's probably like a natural, easy way to do it, and you probably just haven't dug deep enough into the documentation or into Stack Overflow to do it. And I use this advice myself. I'm deep writing something that's crazy and trying to do something, and I'm like, wait, there's probably like a very natural way to do this using the Pandas API, and we'll see some examples of that. Pandas is really good with time series data. The original impetus for Pandas came out of finance. So when you have like single entities that you're tracking over time, we call it longitudinal data or panel data in econometrics, then Pandas was created to handle this case. So Pandas actually stands for something. I think it's Panel Data Analysis System. So that was the impetus of Pandas. It's not just a cute name. And then any kind of arbitrary matrix data where you want to have row or column labels. So if you're just working with something like NumPy or a traditional matrix, you have to like pull out data, index in using numbers. So how did I deal with this? Before Pandas, every object had to have another object that was labels mapping like a column name back to a number. So what's in the second column? It's the address. How do I know that? Well, I have to carry around this like index dictionary that tells me address is 2. So go back. But Pandas allows me to just say like, give me the address, which is nice. Okay, so the first thing we need to learn about just about any library we're going to use is what is the import convention. For Pandas, it's import pandas as PD. And now PD is like holds the Pandas namespace. So this concept of namespaces is pretty core to Python, and I already mentioned earlier that you want to be super explicit about how you import things. So import pandas as PD is pretty standard, and you'll see it in just about everybody's code. I'm going to set some display options just to make it a little easier to read. This just affects how the objects are represented, what summary we see, and you can control differently how you view objects in a notebook versus the interpreter, that kind of thing. So I showed you a little bit how to read CSV files and then told you a little bit about how you may not want to do that. You might. Pandas is a fairly big dependency. So if there's if you're working in a small environment, you may want to just rely on built-in Python functions. But if you have the luxury of being able to install Pandas, then you want to probably use pandas read CSV. So here I call read CSV. I tell it where the data is, and we're in business. It returns a data frame, which we'll talk about what a data frame actually is in a second. But you can see the data is now indexed by row. So there's an integer index for rows here. It just starts at 0 and goes to n. And then all of the headers were parsed out and are made the headers of the file, and we can use those later. And then we can take a little peek at this data. So I like to say that read CSV is the best and worst function in all of Python. Why is it the best? Because it does everything. Does read CSV account for, people started making CSVs and they put like the last 100 lines of it is just like a bunch of notes always. I want to skip that. Does read CSV account for this? Yes, it does. it accounts for everything because there's always corner cases when you're trying to read in data. So in general, that's not like a great programming practice. You don't want to have, in this case, like 60 keyword arguments. But for the CSV reader, I suppose an exception was made. So this is everything the CSV reader and Pandas can do. It handles just about every corner case that you're going to run into, because as all of us know, when humans and data are involved, sky's the limit. Anything can happen. And then you can read about what each of these does. So I encourage you to spend some time with that, and we will. So let's go ahead and take a break, and then we'll come back and start to get our hands dirty. Okay, let's get started again. Having some conversations at the break. One thing I wanted to mention, maybe I should add it to the slide, so I'll make myself a note. So there's a few of you that work in academia or work in a lab. And this is even true for data scientists. You end up working with a lot of people who are not trained as software engineers. And like even explaining to them why it's helpful to be trained as a software engineer, or like kind of pretend to be one on the internet and at work, is useful and makes everybody more productive, is a little bit of a challenge. But then it's like, okay, but like, what does that mean, right? Like, how do you get someone who has a background in, a deep domain knowledge to care about things like Bash, using the terminal, scripting, use Git? Like, why would I use Git? Why would I use version control? What is version control? What's it for? What are some of these best practices? Like they didn't go through training, and then they didn't work as a software engineer for 3 years, where their team lead was like drilling them on all of this and like building them up so that they can have high velocity and high impact. So Software Carpentry is a really interesting organization, and they have Software Carpentry and Data Carpentry. The whole premise of this is to come in and teach scientists how to be better programmers. And to adopt some best practices. There are a ton of resources online, so if you want to kind of Google Software Carpentry, you'll find your way there. There's a bunch of free guides, so even you could go in and instruct people in your organization on how to do this. They offer training for trainers. So I've actually been through the Software Carpentry training, and they kind of start with just kind of some pedagogical points, like how do people learn math? Why are we really good at teaching math? Why is that like something that we learned how to do, but maybe computer science is lagging a little bit? What are some of the lessons that we've learned, and going through some of the literature there? And then, okay, now how do people learn? How can we take those lessons and apply it to teaching some very basic but very important concepts in software engineering as applied to the science that you do or the work that you do in your organization. So it's just a brief plug for Software Carpentry as an org. So one other thing that occurred to me talking to people at the break is that it may be instructive to go through this example. So let's try this exercise. We're still in the reading data notebook, and I want you to use, so we saw read CSV above. We were able to just call read CSV on a CSV file, and it magically returned a DataFrame. I want you to try to do the same thing for the JSON file that's in the data folder. So one thing to note is we peeked at this earlier, so let's peek at it again. So head is this may not work if you're on Windows. I'm not actually sure. It might. But head is a function in Bash. So this is actually executing code in the terminal. So from a Jupyter notebook or from IPython, if you put a bang or an exclamation point in front of the line of code, then it'll actually just pass that on to the terminal or the interpreter. So I call bang, give me the head of this file. I just want to see the first line in this file. That's one way to do it. So there's a few things to note here. This is the JSON file. Each line in this file is a JSON object. So the file itself is a bunch of JSON objects. It's not a single JSON object, which is, you could have a file that is a single JSON object. We don't in this case, so that's important to note. The other thing is that each line in this file repeats the headers. So it's what we might call like a record or row orientation versus a column orientation. So for a column orientation, we may have address and then a list of all of the addresses for each of the records. That's not what we have here. Well, we have like address and otherwise known as name, are going to be repeated again and again on each line. It's redundant and inefficient, but is often the way that we get data back from the web, depending on how we ask for it. So you'll need to kind of note those two observations to be able to read this data in. So take a couple minutes and try to do that. If anybody has questions about that or anything else under the sun, throw up your hand and I'll come by. Try not to cheat, but it's okay if you do. Do you remember how to read the documentation, how to get help in the Jupyter notebooks? Sure. So we can use tab completion. I don't think I mentioned that earlier, so that's really nice. I have no capacity for memory. If I didn't have tab completion, I wouldn't be able to write a single line of code. So read JSON tab, open your parentheses, and then shift tab, right? Shift tab, tab. Opens up the documentation, or you can use the question mark. Does anybody want more time? Did anyone solve without cheating? A couple people. What was the trick? What are the arguments that you need to use? Yeah. Yep. So the comment was you need to know two things. One, to use the orient keyword to tell it that it's oriented as records. So what does this actually mean? It means that, as I pointed out above, each one of these has the name of the column in the record, right? So what does a records orientation mean? It means that each one of these is a JSON object that has the key, which is the column name, and a single record. The alternative is that it could be the whole column, as I mentioned. And you might want to do this because it's good for things like compression, but for our purposes, we have a record orientation, and lines equals true. So lines equals true is saying that we have a bunch of JSON records in this file. It's not a single JSON record, and I want you to go through the whole file and parse them all out. So
It works without the orientation argument.
it may be the default.
Yeah, but there's tricky part in documentation. According to documentation, it shouldn't be default to records, but it does work in this case. I'm not sure why.
Me either. So maybe it tries to guess.
Yeah, maybe.
So the comment was if you leave out orient equals records, that it still works. Your mileage may vary. So, I mean, the lesson here is that you always have to read the documentation and know your data a little bit, and then try some stuff out. So, like, no line of code in this entire tutorial fell out of my head correctly. I think I'm confident saying that. Like, how did I like write this tutorial? How did I sit down and do this? Well, I knew I wanted to work with this data set. And then I knew where I wanted to get. I wanted to do some modeling, and I was like, let's just get there. And like, what parts of Pandas do we have to use along the way to get there? And what are the like stops that we should take along the way? And to do that, I made a ton of mistakes and kind of relearned a lot along the way. So there was one question that I got around nested JSON. So if you actually look at what we read here, you see that the location parameter here, or the location column, is actually nested JSON itself. So if any of you come from a kind of a geospatial or GIS background, this may look familiar to you. If not, don't worry about it. But that location column itself is nested JSON. Like, does it go in and parse this out for you, or do you have to parse it on your own? Exercise for the reader, but we are going to see how to do some interesting things with read CSV in a bit that would probably get you further along in this for this as well. Only thing I'm going to say here is that the requests package exists. So if you have to go out and read data from the web, if you have to pull down websites, if you have to scrape the web, if you have to interact with any kind of RESTful API, you could do it in pure Python. Python has batteries included. The request package is incredible and great, and you should use it. That's my pitch for that. So how did I actually get this data for the tutorial? I went to the Chicago Open Data Portal, found their API, and used requests to download it all. And I think there should be a script in the repository of how I actually did that too, if you're interested in reading about it. We'll see this again later. Probably should move this up to part of the Python parts, but this is a handy thing that you can do in Python. We'll see why in a bit when we come to some kind of idiomatic Pandas code, but you can split a line of Python across multiple lines if you use parentheses. So this isn't a tuple. This is actually a single string. And just because I've put the parentheses around it and split it up, it's allowed me to split it across lines. So often, like if you look at an example right here, I have a really long URL, and I didn't want that URL take up more than 79 characters because I'm OCD and I'm pretty rigorous about the 79 character lines. You can just split it across multiple lines by sticking parentheses around it. So that's the kind of use for this. And then you can see that I'm not lying. This is just like butting them all together and making it a single string, which will be handy in a second. Okay. Now getting our hands even dirtier. So now we're going to do some fun stuff. So we're going to take a larger sample of this Chicago health inspection data, and we're going to kind of dive deep into it and get it into a format where we can actually start gleaning insights. So I've mentioned already this word DataFrame. I think it comes from R, but that this is a little bit of a port of a concept in R over to Python, and the concept in R was basically stealing relational algebra from SQL and re-implementing it in a different language. And Pandas is a little bit the same thing. So what are the key features of the data frame? So the data frame is it's a data structure that holds multiple columns and has column labels and row labels. So what are some of the key features? Like why do you want to use Pandas? I've already kind of given the top lines, but these are a little bit more of the details. It handles missing data. So this is pretty key working with any kind of real world data. You need intelligent handling of missing data. You can do computations across missingness, that kind of thing, impute data, that kind of thing. Data frames are mutable, so you can add columns. This becomes a little more challenging with some of the other data structures in Python, like array-oriented data structures. You can insert columns, you can delete columns. You get automatic data alignment. We'll see what this means in a bit, very specifically, but imagine two time series that don't match up. So you don't have an observation for Monday, July the 5th, and one of them you do in another, and parts where they do overlap, and you want to add those two together, Pandas will just align those for you. I have lived in a world where I had to do this by hand, and it was horrible and awful. This now lives under the hood, and Pandas does it for you, which is really nice. Very powerful and flexible GroupBy functionality. So a lot of you said you were familiar with SQL, so the GroupBy concept is probably not too foreign. For those of you that are not familiar with GroupBys, it's just this concept of splitting up data based on some key, like putting everyone from a single city into a single data structure and everyone from another city into another, applying some function. So say you want to like sum within cities, you can group by city, sum over it, and then jam it all back together into a single data frame. So that's the split, apply, combine paradigm. Pandas makes this really easy. You can do intelligent label-based slicing and indexing. So I mentioned earlier that instead of carrying around a mapping from column names to numbers, you could just index by label, and we'll get into that. You can merge and join data sets. You can reshape, you can pivot a data set. You can even have, instead of just having a single index or a single label, you can have multiple rows. So you could have like time and entity, things like that. There's a lot. We've already seen a little bit of the I/O tools. We're going to go through in a little more detail some of the read CSV functionality. And I've mentioned already the time series functionality. So like resampling, upsampling, downsampling, taking moving window functions over time series, that kind of thing. Pandas makes that pretty easy. Okay, so let's start to dive into the data frame data structure itself and see what some of these niceties are. So I'm going to use our read CSV function. I don't have to pass any arguments. This is relatively clean. There are two things that index the rows and the labels. The first is this attribute called index. So in this case, we have a range index. So this is the labels for the columns. It doesn't know anything about how we may have labeled each one of these site visits. Remember, this is a visit to a restaurant to do a health inspection. And we haven't told it anything about how would we refer to these. So it just gives us what's called a range index. So from 0 to 25,000. So there's 25,000 visits in this, indexed from 0 to n. And then the columns. So the columns are actually the headers of the file, and you can access that through the columns header. And the columns itself is an index, and it has labels in this case. So head is a handy way to peek at a data frame. So you perform an operation on it. You want to see if it did what you thought it was going to do. You call head. We already saw how to do head in Bash, and head is also a function in R. And it's just give me the first 5 rows so I can just kind of look at what's going on. And the thing to note here is that we have this column called inspection ID. So we might think inspection ID is a pretty handy identifier and something that we may want to make into our index because it's a unique identifier, hopefully, for each site visit, right? So when we refer to a site visit, we might want to refer to it versus with its inspection ID versus just saying, give me the 3rd record or give me the 5th record. So we can set this column to be the index in the data frame by using the setIndex method. So now we have a 64-bit integer index. It figured out this was a 64-bit integer when we read it in. And now the index is this column. So the column no longer exists in the data frame, and it is available through the index attribute. So I'm sorry?
Doesn't that mean that there's 25,000, 0 to 25,000? Yeah.
There are 25,000 inspections, and each one of them is now identified by some unique identifier, whatever the app or however they enter this information into the inspection. So it's not, the index is no longer 0 to n, but we're going to dive into a little bit the details about what that means in a second. Oh, it's not printing everything out. No, this is a handy representation of the index object. And like you saw me use set option earlier, you can change how it displays things using set option. It's another thing that has a ton of different ways to deal with it. They're all there, but it's not showing them to us. Question? The question was, what if you index on something that's not unique? I think it'll let you do that. Last time I checked, it'll let you do that, but you may run into having some trouble. You may have a bad time. But I'm fairly certain it'll let you do that. And I don't know if you can enforce it. I don't, there's a way to check for uniqueness, and we'll see that in a bit. Verify integrity, that may be. Check for duplicates, yeah. Yep.
When you call dat.index,
yep.
Line 2,
yep.
very top, above,
yep.
what is that?
So the question is, what is this range index? So it's very similar. So this used to just give you all of the integers. It used to just assign an int64 index 0 to n, and it was like, but that's wasteful. So having all of those held in memory, we didn't need it. So we created an object that acts like that, but it just doesn't actually hold all of the numbers. So it's the same, it's similar to just range. So this doesn't actually put all of these numbers into memory. So I'm not now holding 25,000 numbers in memory. What I have is an object that knows how to go from 0 to the next one, to the next one, to the next one. So when I iterate through it, I'm going to get these numbers, but they're not held in memory. So you can also say, so start at 0, and then give me every 5th one. So you could do it that way. So this knows how to add 5, then start at 0, add 5, add 5, add 5. Yep.
I guess, I'm sorry, my question should have been, what is the context to dat that index is referring to? Why did it pick out 25,000? I don't see a connection between the data set and the 25,000 that it stopped at.
There's 25,000 lines in the file. There's a health inspection _shy, and then there's a _shy sample. So this should be the number of lines in the file. If it's not, something's gone horribly wrong, and I have no idea. How do I do line count? So there's two things potentially going on. One is that there's new line characters in the actual delimiters. So between delimiters, so there's like a text field in there, and this is one of the things that like read CSV handles for us. It realizes that this is like if you think about it, a cell in a spreadsheet, there may be new lines within the cell, and it skips over those because it knows it's in between two quotes, and then it reads in the file for us. I think that's what's going on. So if you remember earlier when I kept printing line, the last line in the file, it was like a bunch of text, but it actually was like the middle of a record, and I think that's what's going on. There's another question in the back. We're good? Okay. If that's not the case, then something very odd has happened. I don't think that's right. So, okay, remember we just set the index to inspection ID. So now if we peek at the data frame, we actually see this inspection ID kind of nicely printed out for us in this HTML table. So this is a nicety. This is an example of the notebooks playing well with the Python objects because the data frame representation was written in a way to use HTML and JavaScript, and the notebook knows how to take advantage of that. So this is one reason you might want to work with a Jupyter notebook when you're doing data exploration, that kind of thing. So indexing. So we want to look at a column in this data frame. You can just use attribute lookup. So here, if I want to look at the address, I just use dta.address, and I get back what's called a series. So this is the other main object of Pandas, and it's like a data frame, except it's one column. That's the difference between series and data frames. You can do different things slightly differently with them, but for all intents and purposes, dta.address gives us back a series. And you see we still have the index for each one, but then we see the column here, and it's just the address. So you can also use what we call like the get item syntax here with the square brackets. We've already seen this when we indexed lists, etc. Why might you prefer one over the other? So when the first CSV that you get, all of the column names are going to be the weirdest things that you've ever seen. Why would you put % signs and new lines and spaces in the column names? I don't know, but they'll be there. So this may be like address 1 or something like that. This is not a valid Python identifier because a Python variable name can't have a space in it. So I can't, if it were address 1, I wouldn't be able to do like, that doesn't exist, right? You can't do that. So instead, you may have to use this syntax. But it's the former is syntactic sugar for the latter, if it's possible. So if you want to preserve the data frame, so remember we got back a series, but sometimes you want to get back a data frame, and we'll see some examples of this later. You can pass it a list. So here, instead of just saying address, we gave it a list of which it only has one item, and that item is address. So now you can see it looks different, right? Because it's a data frame. Series don't look like this in notebooks for now. So that's interesting to know. It's a handy little shortcut. But the real use for being able to pass a list is to get back multiple columns, right? So a list is an iterable. It contains multiple things. Let's put multiple things in it. Let's get back both the address and the inspection date, and we do that by just passing both in a list. And you can index by rows using two things, loc and iloc. So we call these accessors, mainly because it's this dot, and then it's a thing that allows you to access kind of functionality of the data frame in this case. So first, we'll look at loc. So loc does label-based indexing. So remember we made the labels of the data frame into the inspection IDs. So now we can just ask for specific inspection IDs. So here I want the records that are these two IDs. So I use loc, and I ask for them, and I get back the two records. Yep, question.
So when you have two square brackets, it returns a data frame, and when you have single
Yep, the question was if you have a single item, you get back a series. If you have multiple items within a container, you get back a data frame. That is correct. And let me make sure that is correct. That's definitely true for columns. Let me see if it's the same for loc. I don't actually remember off the top of my head. Yeah, consistency. Good. So this is a series, but it's a series of a single row. And so earlier we took out a column, now we took out a row. So we're immediately going to confuse things and then explain to you why there's two different ways, because it's confusing. iloc. So what does iloc do? Integer-based indexing. So I is for integer here. So now I don't know the inspection labels. Why would I know the inspection ID of any of these records? Like offhand, I wouldn't. But I want to peek at them, and I want to look at the 0th one and the second one. So the first and the third item. Use iloc, and then you can just do normal integer-based indexing. So that's the difference between loc and iloc. One uses the labels, one uses integers. So this question about consecutive integers earlier, you can still, once you assign an index that's meaningful to you, you can still use just regular indexing, 0 to n indexing, using iloc. And both of these support the Python slice notation. So slice notation in Python is just saying start at this element, stop at this element. And in pure Python, the last element is not included. And then here's the step. So we saw this for range earlier. Give me every third item, that kind of thing. That's what step's for. So with iloc, sure, that makes sense. Give me the first 5 records, 0, 1, 2, 3, 4. We do that with kind of :5. So we got the first 5 records. You can also do that with labels. This is amazing. So you, without, if I wanted just all of the records up to this ID, I can just say, omit the start, give me everything up until you see this label. One thing to note here is that label-based indexing is actually inclusive of the last element in Pandas. That's a little bit of a difference. So these IDs are not sorted, right? Like this is not increasing or decreasing. It's just taking the first one and the last one that you asked for and allowing you to do kind of slice notation like they were indexed and sorted. This is where it's kind of like magical.
So
Yep.
once again, does it sort the index when you use this syntax?
The question was, does it sort the index for slicing?
Yeah.
No, it does not. It just looks at the data frame, figures out where the last one is that you want, and gives you everything before that. So these are actually giving you back the exact same thing, but I went about asking for it in 2 different ways. But they're not sorted at all. You could sort, like we can certainly sort this data structure, and we may later, but it's not sorted by default because that's an expensive operation, and Python does its best to like not do extra computation, extra copies, that kind of thing. The question is, can you do this for columns? Yes. Slicing works across columns as well. So you can say, give me everything from address to inspection type or whatever.
Can you have more than one index?
The question is, can you have more than one index? You can have multiple levels in an index. So you could index, we'll see an example of this in a bit. I'll come back to that. You can, you probably don't want to, but I'll come back to that too. It makes things a little complex. So you can combine row and index labeling, row and column indexing, I think that should actually say.
How would you do label-based, raw indexing, integer-based?
The question was, how do you mix the two? So we want to do label-based row indexing and perhaps column-based column indexing, number-based column indexing. I don't know. Let's try. I don't actually remember. One of these may do it. So let me cover this first. Use a comma to separate the rows from the columns. So here we have like a slice notation. So give me the first 5 rows, and then give me the 0th column, and give me the 5th column. And that's this. or we can do label-based indexing. So give me everything up to and including this inspection ID and give me these column names. That's a little more natural. So the question was, can you combine these? The answer is maybe. Maybe not. You would probably do something like this. So you used to be able to do this, but I think it was like too confusing and there were too many edge cases, so it was actually taken out. So I think I would do something like this. Explicit is better than implicit because implicit was hard to maintain. It's good advice for good reason. Okay, so far we've explicitly made an index. What we're going to do now is like the next step in any data cleaning process, right? So the idea here is we're going to get to a data set that we can actually use to do things. So once Pandas tries its best to do type inference when you actually read in the CSV. This is an integer, this is a string. I don't know what this is, so I'll default to some kind of like arbitrary any type container. But we know the types of our data, so let's start to apply some of them. So Pandas has some functionalities that are added to the core Python datetime functionality, the like ability to handle nanosecond level data, this kind of thing that's become super important when you're doing data science and scientific computing. So we use the pandas2 datetime function. We want to change these inspection dates to pandas datetime types, or NumPy in this case. So we use the apply method to do this. Apply on a series takes a function and applies that to every row in the series. So apply can be super handy. So what did we just do here? We just changed inspection date and then we assigned over it, and that's fine. We assigned a new type to inspection date. It's a datetime type now. So it looks a little different than it looked earlier. And you can see here that D type stands for data type, and it's datetime 64 with nanosecond resolution. So now we might want to deal with zip codes, right? So whenever you read in a zip code, this is if you work in SQL and you work with like address data, you've run into this already. But as soon as you read in a zip code, like by default, it thinks it's an integer. And the problem is that in Boston and other places, zip codes start with 0. So it'll clobber that 0. So actually, you probably need to carry around your zip code as a string or some other 0 padded type. So we're going to write a function that converts zip codes from either floating point or integers into a string, and that pads it with zeros. So how do we do this? We're going to use NumPy here. So NumPy is the core package that provides array and type information for the rest of the stack, and Pandas included. And Pandas uses NumPy to handle missingness. So missingness in NumPy is this mp.nan, so not a number. This is just a singleton that says this is missing data. So if we get something that is nan already, so when Pandas reads in data and it finds something that's missing, it just applies nan to it automatically for you, which is nice. If we have a nan already, just return it. Return nan. We could have returned zip code here. Otherwise, try to cast that floating point number to a string and pad it with zeros. So this is, I'm not going to get too much into this, but this is how you do kind of string formatting in Python, or one of the ways that you do string formatting in Python. The curly braces here are just saying, we're going to have a string, and what's in here, we want it to format according to some rules. 0 here means 0 pad. If we have less than 5 digits, 0 pad it. Make sure there are 5 after the decimal place. Don't have any digits. So and then this is going to be a floating point number. So we're going to cast this to a string that's 0 padded and is 5 digits. So zip code, and then we're going to return it. And then we just saw how to use apply. So we just take this function and we apply it to every row in the data frame that's a zip code. And then if we want to go look at our zip codes, Chicago doesn't actually have this problem, but it's good to know how to do. Zip code looks the same, but this is now a string and not a floating point number. So I already mentioned kind of what a data type is, what a D type is. D types is an attribute on the data frame, so we could look and make sure, yep, inspection date is date times 64, we converted it, and zip is this object format now, but we just cast it to a string. Basically, Pandas, for like technical details, uses objects to represent strings. So anytime you see object, it's usually a string data. So that was one way. Yep, question.
How did it get to be a float in the data to begin with? Is that just something that occurred naturally?
The question was, why was it a float in the data to begin with? And it's because Pandas like sniffs out the data a little bit, reads the first few rows, and tries its best to figure out what type this is. And what do zip codes look like? Numbers, right? So it's like, oh, this is a floating point. And it didn't realize it just clobbered all this information for you.
So even when they returned it was a string.
Yep.
Zip code is a string.
Yep.
Why is it showing as object?
So the question was, zip code is a string. We just made it a string. Why is it showing as an object? And the answer is that Pandas uses the object D type to hold strings. And the reason for this is, like, if you think about it like an array, arrays will hold data in memory next to each other in RAM. And so, if you're working with SQL, when you call something a string, you have to tell it how long the string is. So you have to tell it like the max length so that you can actually you can allocate memory and then hold the string in there. And then there may be wasted space. Pandas just doesn't try to do that. NumPy does. So if you hold strings in a NumPy array, you have to tell it the length so that it can just do the memory layout. But Pandas avoids that whole problem by or benefit by holding everything in the object D type, because the object can contain anything. So technical reasons, but you can still operate on it like it's a string, and we'll see how to do that. But when you see this object, it's probably a string. It can be anything. This is like a little bit the any type of the Pandas world. So info is a useful method to be aware of. It's one of the first things that you usually do when you load in data. What's going on? How do I get information about this data frame? It has 25,000 entries. The index goes from this to this. There's 16 columns. Some of these columns have missing data. So this is how many non-nulls they are. And you can already see this object D type, right? Because address is a string, name is a string, city is a string. So that's what the object D type is for. So what are the D types that we have? 12 objects. Memory usage, this is heuristic. If anybody's tried to do memory accounting, you understand how difficult this can be. Because operating systems are smart, but it's a good rule of thumb to go by if you need it. So we used apply to change the D types and apply a function to each. We could just use as type if it's easily castable to a type, if we don't have to do like the complex logic NaN handling like we did in the zip codes and the padding. We just want to like convert a string to an integer to a string, and if you just called int on the string and it works, then you could do that. So like, if this works, then we could just do as type int, and it would cast for us. Here we're going to cast these to what's called a categorical variable. So if you're familiar with R or have some statistics background, these are often called factors. So think about mode of transportation, like train, bus, bike. So that's a factor variable or a categorical variable. Why might we want to cast them as that? Well, it's expensive to always have train, bus, bike everywhere. We can actually just call that 0, 1, and 2 and have 0, 1, and 2 map to the actual categories somewhere else. We don't have to carry around all that information. So you may want to cast it to a categorical type. So a categorical type is something that only exists in Pandas because it's handy. So this is not a NumPy type. So if we just say as type category, then we can make results the risk level associated with the findings in an inspection, the inspection type and the facility type into categories, because there's only a certain number of them. another handy method is the select D type. So if I want to just look at the categorical types, I can say, give me just the categorical types using select D types. So select D types category, and you can see like facility type, restaurant, mobile food dispenser. Inspection type, was this just a general canvas? No idea. They're trying to reapply for their license, and we need to go check them out, that kind of thing. And finally, there's, as we saw earlier, there's this location type in there that is itself a nested JSON object, but it's redundant because we have latitude and longitude, and we can just work with latitude and longitude. So how do we delete a column in Pandas? Same way we delete anything in Python, del. So that's how we want to. That's how we want our data to look when we start to work with it. Those are the types we want. This got rid of the cruft. We parse the dates. We can actually do that with read CSV. So I may kind of just skip to the punchline here. But read CSV has, like, how I mentioned earlier, it's the best / worst function. It can do all of this stuff that we learned we had to do, but we didn't know to do it up front. So quite often, like, this is a kind of a Pandas best practice, and one of the reasons I use notebooks and this kind of thing is to like peek at the data, iterate through it, use the nice parts of the notebooks. But in the end, what we just want is like, what's like the one-liner? How can we encapsulate all this information in a single function call? And then it's that single function call that we might copy over to our like production code. So we might copy this into our editor and save it somewhere. So we'll go through this a little bit. So we saw that we wanted to assign an index. Inspection ID is a unique identifier for the inspections. So we can use this index call. We know that dates are in this inspection date column. So we use the parse dates argument. Why is this a list rather than just a column? It allows you to handle the case where like your days, months, and years may be in different columns, and you want to just put them together. So automatically parse the dates. Figure it out for us. We can do that. So we have this float to zip function that we wrote earlier. So we can pass this function to an argument called converters. So take the zip column and apply this function while you're reading the data in. So there was a question earlier about, hey, we have nested JSON. Can we handle that? Can we clean that as we're reading the data in? The answer is yes. And one of the ways you could potentially do this is by using the converters argument. So here I pass it a dictionary, and I can do some kind of like on-the-fly processing of the data as we read it. As far as we're concerned, that's how it happens. And here we're saying the zip column, apply this function as we read it in.
Why did you not use apply?
So the question was, why did I not use apply? So the goal here is to try to take all of the functionality that we discovered iterating through and stick it in a single place. So we could use apply after the fact, and that's like, it's just as valid. And fine, and I don't know. I would argue whether one's more correct. One is certainly the way that you iterate through things, and then one may be like how you encapsulate what you learn for later. So I would often like maybe even accompany this with like a code comment, like so not what it does, but why you do it. All code comments shouldn't be what the code does, because the code tells you what the code does. The code comment is to tell you why you did it. And in this case, zip codes can start with 0, so we're going to cast it to a string. But it would be just as valid to use apply later. This is just like a kind of a best practice, and we'll come back to that a little bit when we pull it all together. So 2 things here. So we deleted the location column earlier. We can just not read it in. There's a use calls argument. So this is a way to kind of whitelist columns that you want to use. So we say use every column here that's not called location. And how do we do that? We use what's called a lambda function to do this. So a lambda function is a way to write anonymous functions in Python. What does that mean? It's a function that we didn't give a name to because we don't ever need it again. So we just allow it to only exist here. And so we're actually passing a function, and we use lambda to do it. So what is this actually saying? So lambda, hey Python interpreter, there's a function coming. What are the arguments to this function? It's going to take, we're going to call it call, and it's going to take a single thing. After the colon is the kind of one-liner. So column doesn't equal location. If that's true, then read that column. If it's false, then don't read that column. So if if it is location, we won't read in the column. Questions about lambda functions? This is like a little wild and weird. Yeah. The question is, can we pass an array or a list to use column? And I believe, as with everything in Pandas world, the answer is yes. Let's see. Use calls equals none by default. It's hard to read. Array-like or callable. Yes. So yeah, you can pass an array of booleans. So I could have said like false, false, true, true, true if I already knew the answer, but here I didn't. So I wanted to be cute and use a function. So a callable in this case is a function. Anything that can be called is a callable in Python. Or array-like, so a list or an array or a Pandas series itself, that kind of thing. So the next thing that we did is assign types to our variables, to the categorical variables. So we cast the categorical variables to category. We do that with a dtype argument here. So we pass another dictionary, and we just say, if this is the column name, this is the dtype we want. And then look at one of them. So we can actually, so we indexed on a column, get back a series. Series have the head argument, so I can just peek at the series here, and we see they're now the risk level. The D type is category. What are the actual categories that are in risk? All. So this has high, medium, and low risk violations. The trifecta. And you know, some are just high risk, medium risk, and low risk.
Can we go back to that?
Yep.
So results, I guess, is the result of the inspection.
Yep.
Risk. That's just listing the. Are this just listing columns? I'm kind of confused what we're getting out of that.
Sure. So the question is kind of like, let's unpack this a little bit. So let's back up for a second and look at what are the columns in this data frame. Address, otherwise known as name, city. But since we've kind of peeked at our data and we knew what it was and what it is and what the type should be, we know that result. So let's actually look at these. Results, risk, inspection type, and facility type. So results here, these are the column names, results, risk, inspection type, and facility type. We know that there are a finite number of answers for the things that these can be, right? So there's only a set of like columns or categories that these can have. Pass with conditions, pass, fail, you know, the risk level, and then all the inspection type, and the facility type, you know, is it a daycare center, is it a restaurant, like where are these people serving food? And we know that there's only a, you know, roughly, well, countably infinite or finite number of categories this can be depending on philosophy. Yes. So the question was, can we state again what the category type is and why we need it? We're gonna see some of the like nice things that the category type allows us to do. The answer is twofold. One, like memory and efficiency reasons. So like now that these are category types, this is like a little bit of an implementation detail, but this is just how we see it when we look at it, but this isn't how it's stored. So it's actually stored 0, 1, 2, and it allows us to save space and allows us to do some computations much more efficiently than if we were having to like parse out strings, like counting, that kind of thing. And then when we actually do operations on a category type, the operations that we might want to do are different than what we might want to do in a numerical type. For a numerical type, we may want to take the mean, right? For a category type, we may want to count how many are in each one of these categories. And by casting it to a categorical type, it allows us to do computations with it more efficiently. So store and do computations more efficiently. So back to your question. Like what is actually going on here? So these are the names of the columns that we want to cast, and then we tell it when we're reading in the CSV, these are the names of the columns that we want to cast, and this is the value that we want to cast them to. So if results was an integer, we could say int here. So it's a mapping from name to type. That's it. Yep. Yeah. Why do we put category here? Because we know these are categorical types. And so we know we want to cast these to category. So that's why we're doing this. The answer is, the question was why can't we put like integer or string here? They're not integer types. We could treat them as string types, but we're going to get some nice functionality out of saying they're categories that we'll see in a little bit.
On your DTA.risk.head.
Yep.
So now I see what you're doing. You could say DTA.inspection-type.head, and you would see what type of inspection there was.
Yep. I was just looking at one of these later. Yeah.
There you go. Okay.
Yep. Yeah.
In your read CSV in the last 3 of these, you used the converter, you used the use columns, and then you used the D type.
Yep.
Could we have dumped that all into one read CSV and then
Could we ever?
basically, an exercise?
So the question was, why did I do this all one by one? Why don't we do it all together? Well, why don't you do that now? If there's any questions, throw up your hands. Does anybody want a few more minutes? Okay. So this is kind of basically just combining everything that we did above, right? So, and then some examples of, you know, making sure our float to zip function actually works. So two things. These are kind of like stylistic and best practice comments. So first is the use of this assert statement. So this is just saying assert. If assert is true, nothing happens. If assert is falsy or false, then it raises an assertion error. So this is just making sure, this is actually kind of nonsensical. But you can use assert statements to program defensively. So like if you write a function that takes a string, you may want to ask, you know, is this a string? Wait. So assert that, you know, something that we got is a string. But if some, you know, there's no accounting for users, and if a user inputs integer when they should have inputted a string, in Python you can't really control for that other than checking. So this is one way that you could. So using assert statements to assert things that you expect may be a good way to do defensive programming. So here we're, you know, assert that if there's a missing string, an empty string, and we pass it to float to zip, that it returns a nan. If not, raise an error. If it works, it's fine, go on. The other thing is, so why did we do this? And the takeaway here, and we'll see it again in just a second, is that this is the way that we do data science, right? So I've kind of mentioned this already, but fail your way through to your result. Iterate, find what you actually want, and then go back, clean it all up, and stick the like clean, smart, simple version at the top of your file, and then you have that for later, right? So you may like keep your script around that you use to like get to, or your notebook around that you use to like get to this final state, but you want to look, you know, like a genius in front of your colleagues and to your future self. You're like, oh, this is gorgeous code. I probably wrote this on my first try. Like we know that's never the case, but it removes the cognitive burden from trying to have to understand like all of this. Why are we doing all of this? I don't remember why we did all this. Why did I even try this like branch and go down this rabbit hole? Well, in the new version of history, you didn't, right? So what we have at the top of our file now, as we continue to do our analysis, is just like this read CSV that encapsulate all the logic. And as I mentioned, you may want to have code comments in here, right? Like things like that. So that's it's basically just kind of a best practice. Okay, so now we're going to dig in a little bit more. The first thing that we're going to note, so what we're going to do is work with this violations field eventually. We're probably not going to get to do a ton of scikit-learn today. You can, I encourage you to go with what we learned this morning and like continue to work on. It's very verbose. The notebooks are very verbose to kind of walk you through this, so they should stand alone, as I mentioned earlier. But we're going to use this violations data to see if we can like parse what's in the violations and maybe predict something like the risk level of these violations, so that you may want to, like, you know, where we started earlier, why are we doing data science? To inform an outcome. In this case, you may want to send a health inspector to somewhere with like a much higher risk of a future violation based on past behavior or something, versus like wasting their time and sending them to like the cleanest McDonald's in the Loop in Chicago. There aren't any clean McDonald's in the Loop in Chicago. But the point being that like we're going to have to like get this data into a place where we can use it. So the first thing to note is there's some missing values in the violations. Why? I don't really know. Humans and data. Maybe there were no actual violations. So it's just an empty string, so that becomes missingness. That was the comment was that was when the inspector got bribed. That may not be far from the truth. But yeah, no, we keep it on the up and up. I live in Chicago, by the way. So the first, as good data scientists, the first question we may want to ask is, are these data missing at random? or is there some pattern to the missingness, right? So if there's a pattern to the missingness, that may trip us up later, so we want to understand why values are missing in the first place. So how do we do this? So we say, take the violations column and ask if they're null. So what does that do? Tab completion. So it returns a Boolean array, right? So for 3 here, row 3, it's true because there's a missing value. So we can actually use this to index into the data frame. We saw indexing with integers. We saw indexing with labels. We can index with a Boolean just as well, thankfully. So use that Boolean series and pass it to loc. So loc takes labels, but it also takes Boolean. So it's like everything that's not integers. And then give me the first 5, right? So head just returns the first 5 columns, remember, and I want to look at these, right? Okay, I looked and I thought about these very deeply. It doesn't look like there's any like actual pattern to the missingness, like, you know, different levels of risk. Some people passed, some people failed. So there's something going on that's wonky. Maybe now we have a data quality issue. We can go ask questions of whoever the steward is of this, that kind of thing, ideally. But we don't have to worry about it for our analysis. So it looks like we're okay. So the next thing to note is that violations has a bunch of different violations in it for each record. So 2 things here. One, I use a new context manager, option context. It's a way to apply a style to a data frame when you're displaying it, but just temporarily. So here I said, you know, just for this code block, allow me to have 500 characters in my columns, but don't allow me to do that all the time because it'll run off the screen and be super messy. But I want to look at this in a little more detail. So the thing to note here is for the first one, there's a bunch of different violations. So violation number 35, or like ordinance number 35 or whatever, walls, ceilings, attached equipment, constructed per code. Good repair, surfaces clean. Okay, that's cool. The next one, food and non-food contact equipment, utensils clean, free of detergents. And then there's some comments. They need to clean the interior panel of the ice machine in the rear of the premises. Like there's probably some slime or something lovely. And the thing to note is that these are separated by a pipe. So this is the pipe character. So for each record, there's any number of violations, and they're in a single cell. So we're gonna have to parse that out. We're gonna have to figure out how to like pull that out. And Pandas makes it 1, tractable, and 2, kind of nice. So now we're gonna start to do this. So I introduced the idea of accessors earlier, loc and iloc. I've talked a little bit about string data and how it's an object, but we can object data type, but we can treat it like strings. And if we use the string accessor on like a field that is a string, we get some nice stuff. So we can capitalize these things. We can center them if there's white space and we want to center them. We can ask if the string contains something through using pandas. And the reason you do this versus like using apply or something like that is this is going to be a lot faster. It's going to have a code path that's highly optimized to solve these problems. And so if you can, you want to use it. So this is a little bit the admonition earlier. If you find yourself fighting the API, I'm writing this crazy function, I feel like this should be part of Pandas. Like maybe it is somewhere. And in this case, like it's in the string accessor for string type functions. So take a moment to do this exercise. The question is, how many violations are in each record? So what does the distribution of violations look like? When you go on a site visit, how many horrible things are happening? Like on average, what's the max, what's the min? So first, think about how to figure out within those strings how many violations you have. And then second, once you have that, you may want to use the quantiles method. So quantiles, return me the quantiles. What's the answer at this quantile? How many violations are there in the 5th, the 95th, the 50th, the median? So you look at the quantile method as well. And again, if there's questions, throw up your hand and I'll answer them. Take a couple minutes to do that. Would anybody like a few more minutes? Couple of nods. Anybody get an answer? So we just kind of want to know what the distribution is. So like, what's the max number of violations that we see? All right, I'm going to spoil the surprise a little bit. I kind of have all of the code here to read in the data, because just to make sure that the solutions are self-contained. That hopefully they all are. Not positive of that. But this is the code that we want to use to get the answer. So let's unpack it a little bit. So when you look at the string accessor, you may have found at least one interesting thing: count. So how are the violations separated? Remember, they're separated by a pipe. So maybe if we count the number of pipes, we'll figure out how many violations are in each record. So we can say count the number of pipes, and then this is actually tricky. We have to escape the pipe. So we actually look for the literal pipe. Pipe means or in regex speak. And then we need to add one, right? Because if there's one pipe, we have 2 violations. If there's 2 pipes, we have 3 violations. So we add 1 to it. The question was, why does the pipe not work on its own? And the reason is because the pipe has a meaning in like fuzzy string lookup that is not, look for the literal character. So what we want to do is like look for the literal character. So there's an example later in the notebook. We probably won't go through it too much in this notebook or the next around regex. So is anybody not familiar with regular expressions? A few people. So regex is a way to look for patterns in strings in computer code. And for let's see. Got to import to be able to tab complete. So let's look for, A or E. Nothing. But now we found E. And so this is saying either look for A or E. and instead of, so, you know, the Pandas will use regular expressions in the string methods, and instead of using a regular expression here, we want to say look explicitly for the pipe. So, other cool thing, yeah, another question. Yep. So the question was, don't we need to put in logic for if there's no violations, there won't be a pipe, or if there's only one violation, there won't be a pipe? That's a good point. Yes. And it's not in here. So I'm thinking, so let me walk through this, and then I'll walk through why I think this doesn't work for the corner case that you just pointed out. So first, you know, if there's two, as I said, there's two pipes, there's actually 3 violations, so we add 1. Oh, no, this will work, because it'll count 0. I was wondering if you add 1 to nan, you still get a nan back. But this will count 0. So what we did was, you know, okay, if you don't actually find any, let's see if there's any examples in here of just one. No one has just one violation anyway. These things come in pairs. But if we actually run this code and look at the quantiles, so the 0th is actually 1 violation. But as soon as you get up to even the 5th percentile, you have 2 violations. So most people have more than 1 is the point here. That's the point. So if they have no violations, it's blank. It gets the nans. When you add nan plus 1, you get a nan. So that accounts for we didn't have any. And so what we actually want to do is probably we can use fill NA to say whenever there's a nan, actually fill it with a number. So we could go back ex post and say there were actually 0. So if it's missing, assume there were 0 violations. My guess is there weren't actually 0 violations. That's why I left it as nan. I'm not sure this handles all the corner cases, but we could find a way. And like close enough for government work. So the max here is 19. Pretty sure that's correct. So it's not all of them, but we don't know how many there can be yet. So the point being here is that why do we do this? We're being a little defensive because what we're going to do is actually expand out these violations and we put them into their own columns, right? So as soon as we start to do some modeling or something like that, we may want to have, what we have right now is inspection. We have, for each row, it's an inspection. What we may want is each row to be a violation. And so that's where we're going. So the first thing that we're going to have to do is take the single column and blow it out into a bunch of columns, and then change it to stack on top of each other. But before we blow it out, I wanted to make sure we didn't have like, I don't know, 1,000 or something. Just being a little careful and knowing your data a little better. So there's never anything wrong with that. And then, like I should mention, we use the quantile method. It takes a list. So I can say, at the 0th quantile, at the 5%, 25th, the median, give me the answer. So what are the counts? So we can just pass it a list. Yep, question. I think the question was like, what's the best practice around how to store data and how to keep data around if we're working with SQL, if y'all are familiar with kind of like database best practices, relational database theory, you may want to normalize your data so you're not storing redundant data, I think is the question. So in this case, like, you may want to join to something else where you store like the expensive data, the big data, versus making it redundantly available within the data frame. And the answer here is that most people, when they're dealing with pandas, like don't think about it like that. They don't think about it in terms of relational algebra, and like it doesn't really matter for this case because you're not probably going to store this on disk like this. So you could normalize the data away and always join when you want to do things, but when you join, you're going to blow things up anyway, and you're not usually storing these intermediate things, so it doesn't end up mattering too much. Does that answer your question? Okay. Okay. So we want to split this up. There's a method called split. We can split on the pipe, and then we say expand equals true. So expand says instead of splitting it up and giving me a list that's one column, go ahead and create me all the new columns. So we can just say split on the pipe, expand, and you see it's taken each one of the violations and put them into a new column, and then given us some not very meaningful names, and padded. Right? So there's 19 columns, and if there was no violation, then it's none for whatever reason. So now we have them in a wide format. What we want is a long format. So how do we do that? We need to unstack the columns, and we do that with unstack. So we've assigned this to a new variable called violations, and we say violations unstack this. So it's taken the columns and it's unstacked them and made it into a long series. And in doing so, we created a weird looking index. So there was a question earlier about, can you have multiple columns as your index? You certainly can. It's called a multi-index in Pandas, or a hierarchical index. So here we have two parts to our index. We have, I think these are the column numbers, and then we have the inspection ID, right? So we had inspection ID and then column number. What this has done is turned the columns and the rows into the row labels. So the first thing, we still need to do some cleaning here. The first thing that we're going to do is drop the NAs. I just don't care about the nans. I'm not going to deal with it right now. Let's punt on that for later. So we use drop NA. That's handy. So now we have the same thing above. We just don't have any rows that are missing data. So we had, because we had padded it with all those nuns and then unstacked it. Now we're going to drop them. Was no information in there. This is spillover. Harder to read or easier to read, depending on where you're sitting. So yeah, that's just some ugliness. Now it looks good. It's actually way easier to see this way. So this is for it unstacked by column. So this is every 0th violation for each record. So it's 0th violation, then all the records, then the first column of violations, then all the records. I don't care about those columns. They don't actually mean anything, because it's not like in order of degree of the violation or anything like that. So what we're going to do is drop it. So one question that may be on your minds but hasn't come up yet is like, what can we get rid of an index? Yep. So you call reset index, and you say drop equals true. So here we have two levels to our index. We have a 0 level and a 1 level. I want to get rid of the 0 level because it doesn't mean anything. So I say reset index, reset the 0th level, drop it, and here's a new construct that's in a lot of Pandas functions called in place. So notice I don't have to assign the result of this. It actually does the operation in place. So I can just say, yeah, drop that, throw it away. And now I have a nice clean series indexed by inspection ID. And so we just took all the violations. It was pretty messy, split it out, unstacked it, cleaned it up, and in a couple of lines of code. So yeah, the comment is inspection ID is no longer unique. That is true. But we could still use it as an index. It's just some weird stuff may happen if we expect it to be unique. One last thing is we split on the pipe. We didn't split on white space, pipe, white space. So we can strip out the white space. So yeah, there are some that start with blanks or space. Let's go ahead and strip it. And now let's check. So there was a question about the pipe earlier. The pipe, you can use the pipe in plain Python. Yeah, question?
Question. When you arrive at this point with
That's a good question. So the question was, at this point, would we try to assign a unique index, or would we just keep going, keep doing our analysis and not care? At this point, I don't care. At this point, I'm not too concerned about the fact that the index is not unique. But if I wanted to make it unique, I certainly could. I could just say violations reset index. It's going to take the inspection ID, make it a new column, give me back a data frame, and now we have a unique 0 to n index. But right now, I don't really care. But good question. Yeah, another question.
Is it also, would it be a weird practice to just like, and take those two as a string, merge them together, add extra digit on whatever your ID is, and then keep going, or is it not that important?
I'm not sure I understood the question. So the question was, you know, should you merge what together? The index and the
Yeah, the newly generated index, the 0, 1, so the location to the ID number,
so that now this still has the inspection ID, but also some semblance of uniqueness.
right.
Nah, I don't really care. At this point, I don't care. If I had a good reason to do that, I might, or I might just, if I did, I probably wouldn't have dropped the index in the first place, because I already kind of had that. So if you think about it, if we had inspection ID, for each inspection ID had a number of records, and then we unstacked those, and then we had an index and then a new column, that's unique. The multi-index that we had earlier was unique, but I didn't really care because it wasn't meaningful, so I dropped it. And it's just like showing you how to do some stuff. Yeah, I wouldn't worry too much about it at this point, unless I had a good reason to. So if I was going to like shove this back in a database, I may think a little more deeply about what I'm doing. So I just wanted to make sure that we did what we were going to do. Remember, you can split lines by using parentheses, and pipe in Python is a bitwise OR for Booleans. So I can just say, does anything start with or end with space? No. Okay, we cleaned. We're good. A quick note on this before we try to get through at least a GroupBy example. .dt is an accessor for dealing with date time stuff. So if you want to just like quickly pull out the month of a date, you can do .dt.month. That's pretty handy. All of the date stuff is in DT. Same with categoricals. There was a bunch of questions earlier about like, why would I want to do that? Well, I get this cat accessor that allows me to like look at some stuff, look at distributions, look at counts, look at frequencies, the kind of stuff you might want to do with a categorical variable. Save just in case. Okay, so we're not done doing data cleaning. So this was kind of introduction to Python for data science. It's not like coincidence that we're going to spend almost all the time learning how to clean data. Before you can do any analysis, you got to get your data in the right format, and that's why Pandas is this like core part of the stack and the thing that you kind of have to learn and get your head around first to go on and do more interesting stuff, exploratory plotting and machine learning, all of that kind of stuff. So I just put the data import stuff in a place where I could quickly import the data, not have to clean it again. So we've already seen info. Describe is another handy method. Describe describes your numerical data to you by default. So this gives you kind of the distribution of latitude and longitude. If you wanted to know what parts of the city were the high density areas. You can also call describe on just category types. So there's, again, a bunch of questions about why would I want to cast them to category types. Well, remember, select D types will pull out all the categoricals if we ask for them, and then we can say describe them to me, and then we get like what are the count and the number of these that are not missing. How many unique variables do we have? So for risk, we saw we had 4 levels. There's 7 types of results, 40 inspection types. What's the most frequent one? What's the top one? Most facilities or restaurants, unsurprisingly. And then what's like the frequency of the top one in terms of the overall number of them. So that's the like short answer to the questions from earlier, like, yeah, 'cause it's pretty handy. Okay, so group by. The most obvious question that you want to answer when you get this data is where should I not eat? And so, you know, the rest of this notebook is like trying to get at how can we figure out where we don't want to eat? First of all, like how do we even ask that question? What does the answer to that question look like? And one of the ways that we may want to do it is by using group bys. So group by the name of the restaurant perhaps, and then like count how many violations they've had. That's a pretty good indicator of whether or not you want to eat in a restaurant. I'll go ahead and steal the punchline because I don't know that we're not gonna get all the way there. Be like very judicious about where you eat at O'Hare. That's the lesson here. It's not just a matter of how many restaurants there are there. They seem to have some issues in this data. So how many result categories are there? We can use value counts to give us that answer. I think there are 7. So you either pass, you fail, you pass with conditions, you're no longer a business, those kind of things. Okay, so now we know the modes of failure, the modes of passing. Can we group on them on these results and start to see like who are the people that show up the most in pass or fail, for instance? This is where we start to use Pandas group by functionality. So we can group by the results, and then we get back an object that knows how to sort those results and that we can ask questions of, kind of treat like a data frame itself. So we can say, we have this group object, give me their doing business as name, and then give me the value counts based on whether or not they passed or failed or whatever the result was. So we couldn't find the Sitco, but if we start to look at failures, so Subway has the most failures. This is sorted by default. Dunkin' Donuts, second most. McDonald's, and then going down all of the chains. So pass with conditions. This is like the end of the pass with conditions. It's just been truncated for display purposes. So I'm going to skip over this. You could sort. You could do an explicit sort if you wanted to. So one thing, we're not going to do this exercise, but one thing to note, things can get a little complicated when you start to do group bys. Especially like, so what you do is you do a group by and you get a result back. So what are the groups? The groups are data frames. So anything that you're going to execute on within these groups, as soon as you split, you have a number of new data frames. You can do anything that you can do to a data frame, but it's hard to think about sometimes, especially as things get more complicated. So one way to do this is pull out an example and then operate on that example. And once you're pretty confident that the thing that you're doing on that data frame makes sense, then you can apply it to all of your data. So how do you do that? Use this get group method. So you create a group by object and then say, give me McDonald's. And then now I have this McD's data frame, and it's just all of the McDonald's. Question, yeah? Good question. So the question was, can you add in the other spellings to McDonald's to help you out here? And yeah, that's like another kind of exercise for the reader, is McDonald's shows up in this data spelled like 40 different ways. And yes, I don't think you can add it in here, but you may want to do some cleaning beforehand to make sure what you're working with is what you think you're actually working with. Like, could I do this and will I get an answer? Yep, there's a bunch of that don't have the apostrophe, and there's a billion other ways to spell it. Yeah. Could I use actual regex here? I think maybe. No, it doesn't look like it. Sometimes it takes a function and you can like do conditional logic because you can pass it a function and it's just, is it true or not? But no, not in this case. You can also pass multiple things to group by. So the other thing to note here is that maybe there were multiple restaurants at a single location. Where I'm from, there was one location that was notorious for restaurant turnover. It was always a restaurant, but it was always a different one. So you may want to look at the violations, based on name and address, something like that. So here, Here we group by the result and the doing business as name. And then we ask for the size. So size is just a way to call like length on the data frame or on the like individual group data frames here. So how many failures with doing business as name? Walk and roll 2. So can anybody tell, like the comment was, I can't believe Subway failed, but can anybody tell me like why this doesn't answer the question like that we've asked, you know, what are the places to avoid? We counted the number of Subway failures, yeah.
You haven't taken into account maybe or we haven't taken into account like the density, like the relationship to how available they are.
Yep, that's exactly right. Subway failed the most because there are the most Subways, right? Subway's the like single biggest chain in the world or whatever. That's why they fail, because there's more of them. They also pass the most too. So that we haven't answered the question yet. And a lot of what this notebook does is actually start to get at metrics that we actually care about that actually start to answer the question for us. So like, what's the ratio of pass to fail? Something like that. Maybe something that's a little more interesting, but is also probably problematic for reasons that I haven't thought very deeply about. So we're coming up close on time here. I'm going to just kind of like do the whirlwind tour of highlights just to make sure that you know kind of the power and the capability that is under the hood in Pandas. Say just maybe 2 words about exploratory plotting and machine learning. Like, you know, you can go spend your afternoon working through this, and feel free to ask me questions. You can find me pretty easily online. So I mentioned at the very beginning that Pandas does alignment. So here I've already split out the data into a GroupBy object, and I want to look at, okay, here are the failures, and here are the pass ones. So chop suey passed, but chop suey's not in the failure name, or in the failure part, right? So walk and roll failed, but is not in the pass, but we want to divide and do like, you know, number of passes over number of fails. We can just do div here, and it'll align the indexes for us. So even though they're not in one or the other, it'll line them up and do the division, so we don't have to worry about that. So we could say, you know, what is who are the people that are failing more than they're passing, and you know, what does that look like? And we didn't have to think about, yeah, but where do I have things? So that's nice. And this is probably the last like kind of stylistic thing I'll leave you with. So you saw earlier that we worked through all of the like problems that we may have, like reading the data and cleaning it up and getting it ready to like start to do this. We're gonna do the same thing again. We do the same thing again here, is like working through all the problems, iterating through, trying to find like how we're actually gonna work with this data. Like what does a clean data set look like? We grouped by, we created new features, we did some you know, transformations, and then once we like know what our best self is, then we encapsulate it in like a single statement, right? So in this case, we're gonna go, okay, what are the ones that have the highest risks by address and doing by name that have had more than 4 visits by a health inspector, right? So some people may have a high ratio because they've only been inspected 3 times. So we wanted to say, you know, what about the people that have been inspected more than 3 times? And so we can encapsulate all of that into a single statement and then chain it together, and we surround it again in parentheses, right? So have a notebook. It's as messy as you want it to possibly be because you're trying to get to what you need. And then once you have what you need, you take your read CSV statement and you take kind of what this is like called method chaining, your chain together method of things that you need, and stick that at the top of your analysis. And then you can go on and do your more data cleaning, you're building numerical features for machine learning, making exploratory plots, that kind of thing. So this is a little bit how we go from messy to the clean thing that we want to save later on. And this is one of the ways that we do that. The question is, can you do multiple nested group bys? Yes. So when you operate on a group by object, when you operate on the things that you split on, it's just a data frame. So anything you can do on a data frame, you can do on a group by thing that you split on. Yep.
Would you prefer to use GroupBy or table?
would you prefer to use GroupBy or a pivot table? It depends on what you want to do. If what you want to do is just a pivot table and you can encapsulate, if you can encapsulate the question into a place where the answer is a pivot table, then use a pivot table. But GroupBy is more general. So you can do a GroupBy, you can do a pivot table functionality with a GroupBy, but not vice versa.
Because usually I just use pivot table because it's the one that I know more about.
Yeah.
I would like to know the advances of using GroupBy instead of pivot table.
So the question is, what can I do with a GroupBy that I can't do with a pivot table? And the answer is everything. So like we have this grouper object that we defined above. We can use apply here. So we can just apply a function. So we can do any kind of transformation that's possible inside a GroupBy function. A pivot table is just has a single use case. It's like a pivot table is kind of syntactic sugar for a GroupBy in some sense. Are there other questions? So, well, I'll say one more thing. So the plotting functionality in Python is done with a library called matplotlib. Pandas has built-in facilities to work with matplotlib, so you can also plot on top of DataFrames. And then eventually you want to get this into a space where you can use it to do things like clustering or predictive analytics, and you may use scikit-learn for that. So this is kind of the progression of an analysis. Clean up the data, exploratory plotting, descriptive statistics, put it into a numerical format, and then pass it to scikit-learn, do some interesting stuff, and then maybe give the answers back to your original data and start to do some more analysis or like get predictive values. Any last questions before we run to the food trucks? Everybody wants to eat. Okay, thank you all.